Now, I just think I should try to record another subject that is probability. Why talk about this word probability? I just feel like the probability itself just contains probability. I don't know, this is I don't know how to express well, just because just several minutes earlier I just think I lose something. The world, I think, is balanced. When you are high sometimes, and then some days you'll be low, or your mean value is just at that point. Another experience I have learned is that what you should do is just try your best to begin to do something. Not earlier, but just if you have that thought, you should do it rather than think a lot about it. But just prepare a lot and never try to act. I think I lost a lot of probability, but today I will continue to talk about the probability just to begin this work earlier. I think it's very value and worthy to record these courses. I think it's an opportunity for me to practice myself, but also recording, a high quality recording, rather than just use some words or try to think. Okay, I will try my best to think and give you a clear mind about what I have learned. Okay, this material comes from my school, BUPT. I think if this contradicts with some law, maybe some days I should delete this video. Hope not to do this. Okay, here we go. The chapter 2, this is beginning. I ignore the chapter 1, but I will speed up. I should speed up and directly to output what I should talk. But in my mind, every time I talk without preparation, I just see something that occurs to my mind. So I don't know whether should I prepare or just to output presently. Now I will doing the later some days. If I have some more time and do some work more carefully, I hope I can do it better. Okay. Always speed up and never rush. I hope I shouldn't be distracted. The rhythm variable. In my mind, the rhythm variable is just like a sign that's defined by some concrete things in our world, like the some objects, some things we do, and some opinion, and some prejudice, some thought. This is just to the random variable just to represent in mathematical expression so that you can use it to do some deeper work. Okay, this is of abstract narration, but I think there are no but, just regularly happens. The variable, there are two kinds in our life, the discrete and the continuous, but the essence is just the discrete. The continuous is just I think it's a form of discrete, because when I learned a lot of subjects like mathematics, mechanics, physics. In the end, just we in the end and at the beginning, we always use the discrete to discover what is the life essence. The random variable, there are many kinds, many examples to represent it and to describe it. This is a variable in the distribution functions, and so there are, for example, the head and toss in a tossing method. I should speed up and some point you never find. Oh, they are smoking. Someone is smoking. I think it is fucking smells. I should have opened the window. Oh no. Really fucking. I should have fired by the smells. Just try to do. Variable means the element of simple space. What is simple space? It is just a space in mathematical space in the area of possibility. It has many different kinds. It has many kinds, like what? I think I should stand up to have a high coefficient. Okay, the element of sample in space with diverse forms. In this chapter, we transform elementary outcomes into numerical values. This sentence is just a key sentence in this chapter. How to make a translation or transformation from the elementary to numerical. So here we go, the random variable and the discrete function of a random variable. Not one random function, I mean the distributive function is really fundamental in this subject. What is the distributive function? It's just a measurement of how what is the possibility at the specific point in specific things, or it's just a statistics to represent as in a way of function. That's definition of a random variable that I should repeat maybe 3 times about the definition. The definition, random variable is a function that assigns a real number to each outcome in a simple space. Assign a real number. Assign. Be careful about assign a real number to each come to. Okay, there are some pictures to show this, but what should we do is just that in this example, tossing a coin with the outcome. This outcome is what is the meaning of that? These are just basic operation of when you do some work, homework. Then we can get a random x defined on the. I think you should what we should we do is just what is the space, possible space is what is that we have to not count that the random variable x is just high and head and tail random variable, the x random possible value and the random event. Okay, I think that these are just the events. I misunderstand that what is the variable. That why b2 to the variable means the number also is a variable. Variable means it can vary, and y is variable x, not x is the abstract variable that means what kind of shape, what kind of the side you can look after a tossing. Okay, the another example is that our experiment consists of tossing 3 fair coins x. What is x? X is a variable that it represents a kind of just one how to say one class of the different things. Like x denotes the number. It denotes the number of heading pairs, but x can vary from 1 to 0, 1 to 0, 5. This is his as 0, 1 to 0, 5. I think it's just its space. But we should know what is the whole space omega. This omega is just okay. Omega means what? Means a specific experiment. All the different outcome is just in this space. X is what it describes one trait of this space. Okay, so x means the variable. X is a variable, but which is in its space is just sum of the space in X. Sum of space, this is the whole space, and sum of space in to be represented by X. This is a function. This is not a function representation, and it can represent the whole space. The event x is 0 is equal to the omega, that x omega etc. is also equals to one specific thing, event in the whole environment. Okay, let's repeat. Some variable is a number, is the sum number, is a specific number. Means what? Means that this variable is a like function in some error that just equal to 0 and is also equal to a specific event in the whole space. The definition of random variable continue with the example. Also, I don't. We just ignore this example. Let's say also x has some error. It's a variable that varies from some error. So this error x, this and this are equal because these are just one-to-one. These are the specific discrete. This is a continuum. I don't mean what that means. I mean that. Okay. I'm a little tricky. The definition of, I think I should check if I record. Oh, I'm recording. The definition of distribution function. Okay, the distribution function is, I will repeat what I have understood, is that it is a function that describes the space, the spaces trait. It is just a statistics of one kind of random variable. Okay, let's have a specific example to show that. Suppose we have an experiment that denotes the number that we have different scenes, but different events represented by the same the random variable. So this stem variable is an abstract concept among the different events, and thus the distribution function is a transformation of the random variable to represent some traits of the random variables distribution, so that we can get some operation that is what is p probability of some random variable equals to some specific time. So we have different kinds, but the total sum is just 1. Okay, there is another representation that x is also can be chosen by a range, so that it's also a representation of different events. Let's continue that. We can define the x in any mathematical formula, but in a specific random space, the x is defined on some of the events. So the events are discrete. So you can choose, even if you choose the one number that is 1.6, 1.6, 9, 10, 11, but there are only the specific events which are defined in the the whole space, the random space, whole space. So you can so another abstract is from the events to the random variable equals to some specific number which are equal. So this sign means what? Means that this is a logic operation, that means they are in the same operational domain. So what this transformation is just use the property of the possible formula property, I think. So another thing that you can see that this one way enlarge what we have discussed, we can make the range to the finite, infinite, from finite into infinite, so that we get something that this from the specific number to some range to then to the infinite range is just a big step from the basic concept to a secondary concept. So this is a introduction to the probability distribution function. This is a more abstract from distribution function referred to the P point D point to probability distribution function referred to P dot D dot F dot. Okay, this is the discrete space, so you just use the summation assignment. So also we use one way we can refer or induce from the infinite to a specific. This is just like twice operation from the specific I don't think this is just of what I think is that from simple to future theory, but with the help of the features theory. The further theory, when we look back at the simple theory, it has the more meaning, so that we can refer to that, we can get the subtraction of the different reference, so that we can refer to a range to a mathematical operation, and this also a basic element is capital F O B, capital minus capital F O A. This will be introduced sooner. Okay, let's review what we have then. The first thing is that we have learned how to random variable. It's just an assignment. The another thing that we have talked about is the distribution function of random variable. Let's continue to introduce the definition of distribution function. Definition is very important, so I should speed up so that we can have more chances to express. Okay, let's repeat again the function capital F of x that associates with each real number x the probability P of x less or equal to x that the random variable x takes on a variable smaller or equal to that number is called the distribution function of x. Or I just repeat, but I don't have to. Let's repeat the thoughts is that it's associated with each real number of probability. The domain is the real number. Each real number x the probability that the domain takes on a variable smaller equal to called a distribution. Okay, this is just a mathematical expression so that we give it further meaning. It's not a principle, first law of this. The abbreviation distributive means cumulative. Use the term cumulative function instead of distribution. CDF is equal to the. So there are two kind of representation is what? The first is the R and X. Thank you for your patience. Okay, I should have wait some minutes. Oh, 25 minutes. Okay, here we go. Thank you very much. I hope this is very and not very useful to all of us, but I think it's a good chance to communicate with others about our mind, to share our minds. Thank you very much. Goodbye.